Please mute your mic, Nigel. Nigel, please mute your mic. Hello, am I audible?
Yes, sir.
Is the screen visible?
Yes, sir.
Copy it fast. Done? Right on ionization energy. Amount of energy required to remove an electron from its first orbit. To n equal to infinity. Ejection of electron from the atom. Copy it fast. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Write it down fast. Let me know if there is any doubt. This is n equal to 1. This is n equal to infinity. This is nucleus. What will be the energy? Right? Any doubt in this? Hello.
Sir,
Yes.
what is that Ne atom?
Again, what?
Please scroll up.
Yes.
So in the bracket, ejection of an electron from
From the atom.
the atom. Okay, sir.
All of you understood this formula?
So please scroll up a bit.
Yes. Read it and let me know if there's any doubt.
Thank you, sir.
Sir, please zoom in.
Just what you want to see. Shivam. Calculate the ionization energy for Li 2 plus ion.
So could you please scroll up? Thank you, sir.
All of you understood this? All of you understood this? Calculate the amount of energy required to remove fifth electron from boron atom. Any doubt to anyone in the previous question? Any doubt to anyone in the previous question?
No, sir.
85 electron volt. What about others? Sumuk, you are in this class? No. How to do it? See, boron has 5 electrons. We can apply Bohr theory only on B plus 4. Is this correct or not? Is this correct or not? Is it correct or not? Boron has 5 electrons, but we can apply Bohr theory only on B plus 4. Yes or no? Am I audible?
Yes, sir.
Are you getting it? We can apply Bohr theory only on this. single electron species. So the electron that we are we are removing is the fifth electron only. Electron that we are removing is the fifth electron only. So we can directly apply ionization energy is equals to 13.6 electron volt into 5 square. That will be 25 into 13.6 electron volt. It will be 340 electron volt. Amod, it's positive. Sai, what you have done? Sorry, Sakshi, what you have done? Abial, how you got 85? Abial, how you got 85? She didn't say 85. Only Sakshi said. Okay.
Sir, can you explain the above part?
I have said that the question is for the fifth electron, right? Now, we do not have to worry about that. Why? Because we can apply Bohr theory only on the fifth electron. We can apply Bohr theory only on the fifth electron. Because Bohr theory is applicable on this species only. How many electrons does it have? B plus 4. How many electrons does it have? B plus 4. Initially, it had 5 electrons. 4 electrons are gone. So now it has only the fifth electron. So we can apply this theory. Directly the formula we have to put. Okay. Okay.
Okay, sir.
All of you understood this? Calculate the amount of energy required to remove tenth electron from neon.
So could you please scroll up a bit?
You have not done that one?
Oh, I have this. I just lost connection. I thought I missed something.
Okay. So you understood the concept, right?
Yes, sir.
Apply on this. Shivam, try this. So Ni has overall 10 electrons. We can apply theory only on this. Formula is same. One 1360 electron volt. Okay. Very good, Spara. So it should be 10, right? It was 10. Then I square it. I have to square it also, no?
So no, it should be 10th. So it is like we should remove all the 10 electrons.
No, no, no. Only the 10th electron.
So yeah, that's 10th.
Okay, okay, okay. Sorry. Sorry, sorry. Okay. Ionization energy formula can be applied to fourth electron of carbon, first electron of lithium, seventh electron of nitrogen, first electron of helium, on which we can apply ionization energy formula.
Sir, lithium.
7th 11 of nitrogen.
Seventh of nitrogen. Who said lithium? Lithium ka we can only remove third electron. Carbon ka we can remove only sixth electron. Nitrogen ka we can remove seventh electron. Helium ka we can remove only second electron. The one who said lithium. Understood? Understood?
I know, sir.
Ionization energy is always
So please scroll up. Scroll up.
Sir,
Done, sir.
yes.
So how did we identify that only 7th electron of nitrogen? Sorry. How did we identify that?
See, we can apply Bohr theory only on the 6th single electron species. Okay.
So can you show me an example?
See, if I take carbon, how many electrons does it have? 6 electrons. So we cannot apply Bohr theory on it. It has 5 electrons. We cannot apply Bohr theory on it. It has 4 electrons. It has 3 electrons. It has 2 electrons. And it has 1 electron. On which we can apply Bohr theory? Tanya.
So the fourth one.
Fourth one, or the F. We can apply Bohr theory only on
Sir,
the
F.
single electron species. Tanya.
Didn't understand.
I have said that we can apply Bohr theory only on the single electron species. Which among them is the single electron species? You understand these charges?
Understood, sir.
So, is this the single electron species?
Yes, sir.
So, we can apply Bohr theory only on this. Okay.
Okay, sir.
What does this +5 means? What does this +5 means? Carbon has lost 5 electrons already. Sania.
Understood, sir.
C +5 means carbon has lost 5 electrons already. Now, if you are applying energy to remove an electron, so which electron you are removing?
So the fifth one.
No, 5 has already lost. Now, if you are applying energy, then which electron you are removing?
So the sixth one then. 5 have lost.
Okay.
Understood, sir.
So wherever you apply this, for example, lithium. In lithium, we can apply theory only on this. How many electrons does it have?
3.
Does it have? Not had. अभी इसके पास कितने इलेक्ट्रॉन्स हैं? Li2+ के पास.
अभी 1.
1, right? So we can apply Bohr theory on it. Okay. How many electrons it has? How many electrons it has lost?
It has lost 2 electrons.
So now it will lose third electron.
Yes, sir.
That's why I written third electron. Understood?
Understood, sir.
If you are not getting it, you can call me after this class. I'll teach you again.
Okay, sir.
Okay. Maybe you have some issues with these charges or all. So you can call me again. I'll tell you again. Okay.
Okay, sir.
Write down separation energy. Energy required to remove an electron from the atom from any excited state. From any excited state. From any excited state. From any excited state. Energy required to remove an electron from the atom from any excited state. Okay. Am I audible?
Yes, sir.
Okay. So can anyone tell me the difference between ionization energy and separation energy? Amal, you only. इधर भी रिमूव कर रहे हैं, उधर भी रिमूव कर रहे हैं, इधर भी इन्फिनाइट पे लेके जा रहे हैं, उधर भी इन्फिनाइट पे लेके जा रहे हैं. What is the difference between ionization energy and separation energy?
So in ionization, we remove from the ground state,
Very good.
and in this, we remove from the excited state of the element.
From any excited state, right?
Yes, sir.
So do you think here n value will also matter?
Yes, sir.
Amal, right? Here n value will also
Yes,
matter.
yes.
While in case of ionization energy, n was not, we were not considering the n value. We were only relying on the z value, right?
Yes, sir.
Sania, understood?
Excuse me, sir.
Understood.
Yes.
So this is not dependent on Bohr theory, no?
Again, what?
This is not dependent on Bohr theory, no?
Dependent means?
Means we have to have
Do you
single.
want to say that are we again now also we are relying on the single electron species? That you want to ask?
Yes, sir.
Definitely, we are relying on the single electron species only. It is somehow similar to ionization energy, somehow different from ionization energy.
Okay, sir.
Okay.
Thank you.
For example, if I say, just wait a second. If I say that this is n equal to infinity, okay, and this is these are some orbits. These are some orbits. So this is your n equal to infinity. Yes. And this is your n equal to 1. If electron is present here and you want to throw it out of the atom, then how much energy required? How much energy required?
13.6.
Ionization energy, right? Madhura, ionization energy, right?
Yes, sir.
Yeah. But if electron is present here and someone asks you, you want to throw it out, can we apply ionization energy?
No, sir.
No.
No, sir.
So then which energy we have to apply? Which energy we have to apply? Separation energy. Hence we are reading about the separation energy. इसलिए हम पढ़ रहे हैं separation energy के बारे में. Because if someone asks you,
So
your
please
electron is
repeat again.
I have said that you can see this orbits in n equal to infinity, right?
Yes, sir.
Figure, you can see the figure, right? So if your electron is present in ground state and you want to throw it
Yes.
out of the atom, you want to throw it out of the atom, what energy you have to apply? What energy you have to apply? Ionization energy.
Ionization energy.
But if your electron is not present in the ground state, it is present somewhere else. But you want the same thing. You want to throw it out of the atom. Can you apply ionization energy?
Yes, sir.
Can you apply ionization energy?
No, sir. We can apply
No.
separation.
Because Amal said that ionization energy is only possible for ground state. Right, Sanika?
Yes, sir.
So what we have to do, we want some other energy. We want some other kind of energy which can tell how much energy is required to throw electron out of the atom when it is not in the ground state.
Sir, but it should be in an excited state, right?
Yes. If it is not in the ground state, it will be in the excited state only. Na? दो ही तो चीज होती है, एक
Yeah,
ground
okay.
state, एक excited state. So understood?
So,
Yes.
Yes, sir.
so when there is a ion formation, the electrons lose from the excited states, no? The electrons.
Depends. Definitely, if you have only one electron, then that will be a exceptional case. Otherwise, only the electrons present in the outermost shell can go out or can be removed.
So when the electron is present in n is equals to 3 in this case, how can it be a single electron species? Because the electrons in first and second orbit, they are still present, no, sir.
But that has been gone, na? If you have single electron, right?
Yes, sir.
No, single electron does not mean it will only be in the ground state. It can be in the excited state also.
Okay, sir. So it depends.
Okay. Yes, pick up.
So it depends on how the scenario is.
Definitely, they will tell you that electron is orbit में present है. Now, what will be the separation energy?
So, sir, the electrons are not always from the outermost shell. It can be from the first orbit also, no?
See, electron, if you have any atom, right? For example, you say, sir, I have calcium.
Yes, sir.
Okay. And you know its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And you say that, sir, I want to remove one electron from it. Can I remove it? Can I remove it from 3s? I'll say no.
Yes,
Okay.
sir.
You can remove that electron only from 4s. Okay. Okay, yes.
Yes, sir.
Okay. Now you say, sir, I have calcium. I had 20 electrons, but 19 electrons I have already removed. Okay.
Yes.
That means you have only one electron.
Yes, sir.
Now you ask me, sir, which energy should I apply? Should I apply ionization energy or should I apply separation energy? Okay.
Yes. Yes, sir.
Then I'll tell you where your electron is present. Either is it in the ground state or in the excited state? If you say, sir, it is in the third state, I'll say apply separation energy. If it is in the first state, I'll say apply ionization energy.
So I was asking like the electrons, they are removed from the higher energy orbits, no, first. So if the single electron species is left or any means it's left, then it will be in the first orbit. If only one
It is
electron.
not like that. If you have single electron species, it may be present anywhere. That's what we have done till now. Energy in the third orbit, energy in the fourth orbit, energy in the fifth orbit. That all was the single electron only, ना? अभी जो हमने पढ़ा इससे पहले, what was this? See this? Yes.
Yes, sir.
Electron in the first orbit, electron in the second orbit, electron in the third orbit, electron in the fourth orbit. That means electrons can be in any of the orbit. That's what you're
Yes,
saying.
Yes, sir. Yeah.
Now, if you want to say, sir, how does it reach there? That I'll tell you in the next topic.
Okay, sir.
वो वहां पर क्यों है? That I'll tell you in the next topic. As of now, I'm saying if your electron is present in that particular orbit and you want to remove it from the atom, you have to apply separation energy. If it is in the first orbit, you have to apply ionization energy.
Yes, sir.
वो वहां पर क्यों है वो हम next topic में देखेंगे.
Okay, sir. Thank you, sir.
Well, all of you understood this?
Sir,
Yes.
sir, is there any, what is the definition of single electron species?
Definition means what? Take
Is
any
there any
element.
definition? Yeah, definition. What is single electron species?
Single electron is any element which have only one electron.
Means only outermost.
What do you mean by outermost?
In the outermost shell.
No, overall. पूरे atom में एक ही electron है. I gave this in quantum number also. See, this is hydrogen. Tanya, reply fast, please.
Yes, sir.
How many electron does it have?
One.
One. So this is single electron species. This is helium. How many electron does it have?
It has 2 electrons.
Now remove one electron from it. How many electron does it have?
1.
So this is single electron species. This is lithium.
So,
Yes.
sir, when we remove, after the removal, if there is only 1 electron, that means it is a single electron species.
The ion which is given to you, it should have single electron species only. You do not have to remove any other electron. In the question, only the single electron species will be given. If it is from the Bohr theory. अगर Bohr theory question होगा, they will provide you only the single electron species.
Sir, didn't understand.
See, we have lithium, right? Lithium has how many electrons?
Sir, 3.
3. Lithium plus has how many electrons?
2, sir.
2. And lithium 2 plus has how many electrons?
1.
So this is the single electron species. You have to apply all your formulas on this.
So it depends upon ions.
Definitely. But you will be given only these ions. You do not worry about that. कि single electron species है कि नहीं है. अगर question आएगा, they'll provide you these ions only. They won't provide you this.
Now I understand.
Okay. Separation energy is clear to all.
Yes, sir.
Should I write? Should I write delta E is equals to E of infinity minus E from some nth orbit. (13.6 electron volt into 1 upon n square minus 1 upon infinity square into z square. (13.6 electron volt into z square by n square.
Sir, are we deriving the formula?
Yes, we are deriving the formula for separation energy. Any doubt to anyone in this? Any doubt to anyone in this?
No, sir.
Calculate the separation energy of helium ion from the second orbit. Very good, Sanika. But have you understood the concept? फॉर्मूला लगा के तो डेफिनेटली आप
Yes,
निकाल
sir.
लोगे. अंडरस्टूड ना?
Yes,
इसका
sir.
मतलब है कि
Yes, sir.
if that electron is present in the second orbit, then how much energy is required to remove it from the atom? And it belongs to helium ion.
Yeah, got it, sir.
Okay. Yeah. Sania, you understood it?
Yes, sir.
Okay. So it is very simple. Orbit will be given to you. Ion will be given to you. Apply the formula z square by n square. That will be the answer. Is this formula different from the total energy formula? Yash?
No, sir.
Has given answer also. Amal?
It's the same, no, sir.
Yash is saying it is different. Yes, why it is different?
So there it is the energy which is bound to the nucleus.
Very good. That was the energy with which it was bound to the nucleus. And this is the energy that we are providing. Right? This is positive. That was negative. Additive inverse. Am I audible to all?
So, but just the magnitude is same.
Yeah, but do not say only negative positive. Understand the concept I'm talking about.
Yeah, yes, sir.
Definitely, only that negative positive is different. But overall concept क्या है कि उतनी energy वो bounded है. And here we are providing that much of energy. Okay, that makes positive and negative. Separation energy, ionization energy is the energy that we are providing. Am I audible to all?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, you have to rejoin then. See, there is some issue. I am also using Fatima ID because this app is also not working. So please rejoin. Cannot see or hear the sound. All of you understood this? I think it's simple. I should not do more questions on this. Excitation energy. Excitation energy. Okay. Have you understood this ionization energy?
Yes, sir.
Yes, sir.
Have you understood this separation energy?
Yes, sir.
So if someone
Yes.
asks you that amount of energy required to go from here to here, what will be that energy?
Separation energy.
Separation energy.
Separation.
And if you want to go from here to here, what will be that energy?
So it will be separation only, no?
It
Separation,
will be
sir.
separation only. तो
Separation
ये दोनों तो
energy.
separation है. But if you want to go from here to here, then that will be what? Or you want to go
Excitation
from
energy.
here to here, then that will
Excitation
be what?
energy.
That will be your excitation energy.
Excitation energy.
One state to any other excited state. That is called excitation energy. Understood? Understood? वन से बाहर जाना है तो
Yes,
आयनेशन
sir.
एनर्जी,
Yes, sir.
किसी और से बाहर जाना है तो सेपरेशन एनर्जी, इन बिटवीन कहीं पे भी ऊपर जाना है तो इट इज एक्साइटेशन एनर्जी. Amount of energy required to make electronic transition between one state from one state to any other excited state. To any other excited state.
Excuse me, sir.
Yes.
Any other excited state can be infinity?
No. Then it becomes separation energy only, na? Or ionization energy.
Okay, sir.
Just we have to excite it. We do not have to remove it. Understood? Understood? So we have already done so many questions on this. We just have to put N1 and N2 value and we'll get the answer. All of you understood this? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir. Write down atomic spectra. Speed of light depends upon the medium in which it travels. Yes, I don't think recordings are there. I'm facing some network issues. But yeah, recording का तो कोई भरोसा नहीं है. I don't think that problem has been sorted out. Can you see the recording of the class now? No, sir. No, sir.
So we don't first
So the last
download it.
recordings are of 24th August.
Yes, 24 अगस्त के बाद कुछ दिखाई नहीं रहा है यार. कल मैंने भी चेक किया था. Okay, write it down. Speed of light depends upon the medium in which it travels. When light moves from one medium to another, speed of light differs. Speed of light differs. As a result, beam of light deviates from its original path. When it passes from one medium to other. You must be knowing all these things in the 9th or 10th class. So just read it first. High wavelength
Sir,
light deviates.
sir,
Yes,
what is that word?
your voice is not clear. Your voice is not clear. I cannot hear you.
Sir, now can you hear me?
Not clearly, but yes, speak up.
Sir,
You just message me. Yes, yes, yes. Ankit, 100%. If I say this is the prism, a white light is passed to it. White light is passed to it. We know that white light has a band of 7 other lights. Vibgyor, okay. Please do not do that. I'm using some other ID, so I cannot make all mute. Please do not do that. Who's this? Am I audible?
Yes, sir.
Yes, sir.
EBL. Can you understand this concept now? This is prism. This is white light, which consists of 7 colors, which were Vibgyor. It had maximum wavelength. It had minimum wavelength. Deviates maximum, deviates minimum. All of you written it? All of you have written it? Am I audible?
Yes, sir.
Yes, sir.
So the splitting of light because of different wavelength
yes,
write down. Splitting of light splitting of light when it passes through prism into band of different wavelength is called spectrum. स्पेक्ट्रा और स्पेक्ट्रम, ठीक है, इसको स्पेक्ट्रम बोलेंगे। This will be called as spectrum. Spectrum. Okay. All of you understood spectrum? When a light is passed through another medium, it deviates from its path, right? It gives the light of different wavelength or frequencies. The continuation or the band of such wavelength is called spectrum. अभी इतना करते हैं, बाकी नेक्स्ट क्लास में करेंगे।
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.